Volcanoes are among the most powerful and awe-inspiring forces of nature. They can create new land, destroy entire landscapes, and shape the climate of the planet. But have you ever wondered how volcanoes are formed, why they erupt, and how they've influenced life on Earth for millions of years? From their fiery origins to their destructive power and their role in shaping the Earth's surface, these geological giants are as fascinating as they are fearsome. A volcano is essentially a vent or rupture in the Earth's crust through which molten rock, gases, and ash are expelled. Beneath the surface of the Earth lies the mantle, a layer of hot, semi-solid rock that churns and flows due to the planet's immense heat and pressure. When this molten rock, or magma, finds a path to the surface, it creates a volcanic eruption. Once magma reaches the surface, it is called lava, and it cools to form new land. Over time, repeated eruptions build up layers of hardened lava, ash, and other volcanic materials, creating the towering structures we recognize as volcanoes. Volcanoes come in many shapes and sizes, but they share one thing in common. They are dynamic, constantly reshaping the Earth's surface. The formation of volcanoes is closely tied to the movement of tectonic plates, the massive slabs of rock that make up the Earth's crust. The majority of volcanoes are found along tectonic plate boundaries, where plates either collide, separate, or slide past one another. 1. Subduction zones. When one tectonic plate is forced beneath another in a process called subduction, it melts as it sinks into the mantle. This creates magma, which rises to the surface, forming volcanoes. Many of the world's most famous volcanoes, including those along the Pacific Ring of Fire, are found in subduction zones. 2. Divergent boundaries. At divergent boundaries, tectonic plates move apart, creating gaps where magma can rise to the surface. This process is common along mid-ocean ridges, but it also forms volcanoes on land, such as those in Iceland. 3. Hotspots. Some volcanoes form away from plate boundaries, above hotspots, where plumes of magma rise from deep within the mantle. The Hawaiian Islands are a prime example of hotspot volcanism, with each island representing a different stage in the life cycle of a volcanic island. Over millions of years, these processes can create chains of volcanoes, massive volcanic plateaus, and even entire continents. Not all volcanoes are created equal. Their shape, size, and eruption style depend on the type of magma and the geological forces at play. There are 3 main types of volcanoes. 1. Shield volcanoes. These are broad, gently sloping volcanoes formed by low viscosity lava that flows easily. The Hawaiian Islands are classic examples, with their smooth flowing eruptions creating vast lava fields. 2. Composite volcanoes, stratovolcanoes. These steep-sided conical volcanoes are built from alternating layers of lava, ash, and rock. They are responsible for some of history's most explosive eruptions, such as Mount Vesuvius and Mount St. Helens. 3. Cinder cone volcanoes. These are smaller, steep-sided volcanoes formed from volcanic fragments called cinders. They are often short-lived and erupt for only a brief period before becoming dormant. Each type of volcano has its own unique characteristics and hazards, making them fascinating subjects for study and observation. Volcanic eruptions are the result of pressure building up beneath the Earth's surface. Magma contains dissolved gases, such as water vapor, carbon dioxide, and sulfur dioxide. As magma rises, the pressure decreases, allowing these gases to expand and escape. This can cause magma to explode violently out of the volcano's vent or flow more gently as lava. The intensity of an eruption depends on several factors, including the composition of the magma. Silica-rich magma is thicker and more viscous, trapping gases and leading to explosive eruptions. In contrast, low silica magma flows more easily, resulting in gentler, effusive eruptions. Eruptions can range from small, localized events to massive explosions that send ash and gases high into the atmosphere, affecting weather and climate on a global scale. Volcanoes are among the most destructive forces on Earth. Their eruptions can devastate entire regions, destroying towns, forests, and farmland in a matter of minutes. Lava flows can bury everything in their path, while pyroclastic flows, fast-moving avalanches of hot gas, ash, and volcanic rock, are among the deadliest volcanic hazards. Lava is molten rock that has erupted from a volcano or fissure on the Earth's surface. Beneath the surface, this molten material is called magma. It forms deep within the Earth's mantle, where intense heat and pressure cause rocks to melt. When magma rises to the surface and escapes during a volcanic eruption, it becomes lava. Once exposed to air or water, lava begins to cool and solidify, transforming into new rock. But while it's in its liquid state, lava can reach temperatures of 700 to 1200 degrees Celsius, 300 to 2200 degrees Fahrenheit, hot enough to melt most materials it encounters. Its otherworldly glow, intense heat, and fluid movements make it one of the most mesmerizing natural forces on Earth. Lava begins its life deep within the Earth, where immense heat from the planet's core causes rocks in the mantle to melt. This molten rock, or magma, is less dense than the solid rock around it, causing it to rise toward the surface. Along its journey, it collects gases like water vapor, carbon dioxide, and sulfur dioxide, which become trapped within the magma. When magma reaches the Earth's surface through a volcanic vent or fissure, it erupts as lava. The intensity of the eruption depends on the type of magma and the amount of gas it contains. Magma with high gas content and high viscosity can produce explosive eruptions, while low viscosity magma often leads to gentler lava flows. Not all lava is the same. Its characteristics depend on its chemical composition, temperature, and viscosity. There are three primary types of lava. Basaltic lava. This is the most common type of lava and is typically low in silica, making it less viscous and highly fluid. It flows easily, creating smooth, wide surfaces. Basaltic lava often forms shield volcanoes, such as those found in Hawaii, where it creates long, slow-moving rivers that can travel great distances. Andesitic lava. Andesitic lava has a higher silica content, making it thicker and more viscous than basaltic lava. This type of lava is associated with composite volcanoes and produces shorter, blocky flows. It can lead to more explosive eruptions as its viscosity traps gases within the magma. Rhyolitic lava. Rhyolitic lava is the most viscous of all lava types, with the highest silica content. It flows slowly and often builds up in domes near the volcano's vent. Its high gas content makes it prone to violent, catastrophic eruptions. These types of lava create diverse volcanic landscapes, each with its own unique features and hazards. While lava is a stunning natural phenomenon, it is also a dangerous and destructive force. Its intense heat can incinerate anything in its path, from vegetation to buildings, while its flows can bury entire towns. Even slow-moving lava poses risks, as it is impossible to stop and can cut off roads and infrastructure. One of the deadliest hazards associated with lava is pyroclastic flows, which occur when explosive eruptions release fast-moving avalanches of hot gas, ash, and volcanic rock. These flows can reach speeds of over 400 miles per hour and temperatures exceeding 1,000 degrees Celsius, making them virtually unsurvivable. Another risk is lava bombs, large chunks of molten rock ejected during an eruption. These projectiles can travel great distances and cause significant damage upon impact. Despite its destructive power, lava also plays a vital role in creating life. Once it cools and solidifies, lava forms new land that eventually becomes fertile soil. Over time, weathering and the accumulation of organic matter transform volcanic rock into nutrient-rich soil capable of supporting diverse ecosystems. Some of the most fertile agricultural regions in the world, such as the slopes of Mount Etna in Italy and the volcanic plains of Java in Indonesia, owe their productivity to ancient lava flows. Lava-enriched soils are rich in minerals like iron, magnesium, and potassium, which promote plant growth. Additionally, lava fields often serve as habitats for unique species of plants and animals that have adapted to these extreme environments. In Hawaii, for example, lava fields are home to rare plants like the silver sword and unique insects found nowhere else on Earth. Ashfall from eruptions can blanket large areas, suffocating plant life, contaminating water supplies, and disrupting transportation. In 1815, the eruption of Mount Tambora in Indonesia was so powerful that it caused a year without a summer, leading to crop failures and famine across the northern hemisphere. Volcanoes also pose indirect threats. They can trigger landslides, tsunamis, and even long-term climate changes by releasing vast amounts of sulfur dioxide and other gases into the atmosphere. While volcanoes are destructive, they are also creators. Over time, volcanic eruptions build mountains, islands, and fertile plains. The volcanic soils of places like Hawaii, Indonesia, and Italy are among the most productive in the world, supporting agriculture and vibrant ecosystems. Volcanoes have also played a critical role in shaping Earth's history. Massive volcanic events, known as large igneous provinces, (LIPS), have been linked to mass extinctions, as they release enormous amounts of gases and ash that disrupt the climate. One of the most fascinating aspects of volcanoes is their ability to create entirely new land. The islands of Hawaii and Iceland were formed by volcanic activity, rising from the ocean floor over millions of years. Even today, volcanic eruptions in places like the Canary Islands continue to expand the landmass of our planet. Volcanoes play a significant role in regulating Earth's climate. When they erupt, they release gases like carbon dioxide and sulfur dioxide into the atmosphere. While carbon dioxide contributes to warming, sulfur dioxide has a cooling effect by reflecting sunlight away from the Earth. In some cases, large volcanic eruptions can cause temporary global cooling. For example, the 1991 eruption of Mount Pinatubo in the Philippines released so much sulfur dioxide that it lowered global temperatures by about 0.6 degrees Celsius for several years. However, over geological timescales, volcanoes have also contributed to warming by releasing greenhouse gases, helping to regulate Earth's temperature and maintain the conditions necessary for life. Throughout history, certain volcanoes have captured the world's attention, either through their sheer size or the destruction they caused. 1. Mount Vesuvius, Italy. Perhaps the most famous eruption in history, Vesuvius buried the Roman cities of Pompeii and Herculaneum in AD 79, preserving them under layers of ash and providing an unparalleled glimpse into ancient life. 2. Krakatoa, Indonesia. The 1883 eruption of Krakatoa was one of the most powerful in recorded history, generating a massive tsunami and causing global atmospheric effects. 3. Mount St. Helens, USA. The 1980 eruption of this stratovolcano in Washington state was a dramatic reminder of the power of nature, flattening forests and altering the landscape for miles around. 4. 𝗩𝗢𝗟𝗖𝗔𝗡𝗢, Iceland. In 2010, this volcano erupted beneath a glacier, sending a plume of ash into the atmosphere that disrupted air travel across Europe for weeks. Each of these volcanoes tells a story of destruction, renewal, and humanity's enduring fascination with these fiery giants. Volcanoes have long held a place in human culture and mythology. Many ancient civilizations viewed them as sacred, believing they were the homes of gods or gateways to the underworld. The Hawaiians, for example, revere Pele, the goddess of fire and volcanoes, who is said to reside on the Big Island's Kilauea volcano. Today, volcanoes continue to inspire awe and curiosity. They are popular tourist destinations, attracting millions of visitors who come to hike their slopes, witness eruptions, or simply marvel at their majesty. In modern times, scientists have developed sophisticated tools to monitor volcanoes and predict eruptions. Seismometers detect earthquakes caused by moving magma, while satellite imagery tracks changes in the shape of volcanic domes. Gas sensors measure emissions, providing clues about an impending eruption. Despite these advances, predicting exactly when and how a volcano will erupt remains challenging. Communities near active volcanoes often face difficult decisions about whether to evacuate, knowing that false alarms can be costly, but underestimating the danger can be deadly. As Earth's tectonic plates continue to shift, volcanoes will remain an integral part of the planet's dynamic systems. Advances in technology and research are helping scientists better understand these geological wonders, providing new insights into their behavior and their impact on the planet. Volcanoes also hold promise for the future. Geothermal energy, generated by the heat from volcanic activity, is a renewable resource with the potential to power entire regions sustainably. Volcanoes are more than destructive forces. They are creators of land, regulators of climate, and reminders of the Earth's incredible power. They connect us to the planet's geological history and remind us of our place in a constantly changing world. The next time you see a volcano, whether it's a distant silhouette on the horizon or a rumbling giant on the evening news, remember, it's not just a mountain. It's a dynamic force of nature, a testament to the Earth's fiery core, and a symbol of the planet's ability to destroy and renew.